Okay, so I just want to welcome everyone to this webinar on infrastructure integration, the title being Hydrogen Value Chain Infrastructure Integration Interface Analysis Landscape Review. So that's the project that we've worked on, and that was published in July. So just some housekeeping. The webinar is being recorded and will be made available on the EI's YouTube page in a few days after the event. So if I could ask that all participants remain muted except for the presenters. And at the end, we're going to take questions and answers. And so we'd appreciate if you just put your type your questions in the Q&A function only, and don't put the questions into chat. Otherwise, it becomes a bit confusing. So just to introduce, the speakers, I'll introduce myself first. So I'm Tony Needham, Technical Manager at the Energy Institute. So I manage our hydrogen committee and also our electrical committee and all the associated projects for those committees. I've worked with the Energy Institute for over 10 years. So yeah, I think that's all about me. So over to yourself, Ian. Would you like to just introduce yourself and who you are?
Yeah, thank you, Tony. My name is Ion Moizele, and I work for SSC, Thermal Engineering and Asset Management. I chair the HY2005 working group. Yeah, this working group was established to identify and address common industry issues around infrastructure integration in relation to hydrogen transition. As we continue to build our momentum with hydrogen, the group considered the infrastructure required to link the evolving gas transmission and distribution networks to the variety of existing and new producers and consumers of hydrogen. The project we undertook is divided into two phases. Phase one is the assessment of general interface, and phase two is the overview, technology maturity, and service supply chain. And we are here today for phase one work, which has been completed by Penspen. And I would like to hand over to Nigel to go through the work they have done. Thank you.
So just to introduce myself, Nigel Curzon I'm an EVP at Penspen. I've got about 30 years on infrastructural development, starting off in subsea. I ran Penspen's asset integrity business for about 15 years. Now I run a consulting group within Penspen that provides services to the wider Penspen group called the Centre of Engineering Excellence. The last 3 years, we've been intensively involved in all sorts of energy transition projects, including hydrogen, CO2. I also have my colleague with me, John Downer, who is the project manager for this for this project. Would you like to say a few words, John?
Sure. Good afternoon, everyone. Like Nigel, I've been with Penspen for an extensive period, over 30 years. Typically, in the past, of course, working on hydrocarbon, oil and gas type pipeline projects midstream around the world. Quite a lot of work in Africa. And latterly, taking more study work involvement in transitional projects and reporting to Nigel, working with Nigel and a small team. We interface with the Energy Institute to execute the current scope of work, looking at the interfaces throughout the energy chain. And that's what we're going to report on and present this afternoon. Thanks, Nigel.
Okay, thanks very much. Okay, just in terms of the agenda, okay, well, we've already done the introduction, so I'm just going to cover a few slides on the EI and the Technical and Innovation Programme, and also the Hydrogen Programme, so that will just take around 10 minutes. Ian, I think you've probably already covered your piece on infrastructure integration, but maybe you'll have a few more words to say in between my presentation and Penspen's. And then Penspen will obviously cover the details of the report that was published in July. Just in terms of an introduction to the Energy Institute. So who is the Energy Institute? So we're a chartered professional membership body for people who work across the energy world. We're a registered charity, non-governmental organisation, and we've got 20,000 individual members. We've got 120 company members and 44 technical partners. We also have 100 or in excess of 100 technical committees and sub-working groups delivering on our technical programme. We were formed back in 2003 as a merger between the Institute of Energy and Institute of Petroleum, and we've actually been around for 100 years. In terms of the EI's role, as a part of the EI's 2030 strategy, the EI's role is threefold. We look at attracting, developing and equipping the diverse future energy workforce, also informing energy decision-making through convening expertise and advice, and also enabling industry and consumers to make energy lower carbon, safer and more efficient. So we deliver our role through offering a variety of training courses, both online and in person, such as Energy Fundamentals. We also have various outreach programs to engage future leaders, such as Generation 2050. And we also produce a publication called New Energy World magazine, and that comes out monthly. We host conferences, including International Energy Week, host technical committees and engage global stakeholders, host webinars on interesting and current topics, host technical workshops, collaborate with a variety of industry bodies, including other institutes and associations, and we produce research reports and good practice guidance, and we continue to build on the transition topics. So this just outlines our main priorities, which mainly is building on health, safety, asset integrity, digitalization, and climate resilience in energy. Our focus is on the four main pillars, which is decarbonising fossil fuels, deploying sustainable fuels, integrated power systems and renewables, and better managing energy efficiency. So hydrogen, as you can see, highlighted there in red, is a priority theme, and this topic is included in our technical work programme. So just moving on to speak a few words about the technical and innovation programme. So this programme is delivered mainly through a whole variety of technical committees. We have several dozen committees made up of technical specialists from member companies, regulators, trade associations, and others as invited. The work programme is funded by our technical partners, which we have over technical partners funding that programme. And we deliver on 30 plus projects every year, and those projects are authored by specialist consultants and are directed by each of the technical committees. So just in terms of the technical and innovation programme, so the aim of this programme is to accelerate the transition through collaboration in diverse energy sectors with a more recent proactive shift towards low carbon. The Technical Innovation Programme is a hub of technical excellence for industry. We work with technical experts from over 50 leading energy companies, regulators, academia, and together we pursue shared goals and outcomes. We work with all energy sectors, including oil and gas, including upstream, midstream and downstream, onshore and offshore wind, thermal power, solar, battery storage, power systems, hydrogen and CCUS. And the EI's Good Practice and Innovation Programme is instrumental in keeping people, assets and the environment safe and secure. We've over 750 titles in our portfolio of work, and these include research reports and good practice guidance, ranging from HSE risk management to laboratory test methods, with around 50 titles published annually. And we started to host webinars on specific topics and publications. This just outlines our technical committee or organogram, and you can see there the Scientific and Technical Advisory Committee, or STAC, is at the epicenter of that programme. And these are all the technical committees, the main technical committees that are managed via that programme. There's 44 technical partners that sit on STAC, and they are also represented on the majority of these technical committees. And STAC approve and fund our annual programme of works. So the committees cover fuels and fuels handling, health, safety and environment, and also the transition. So the energy transition is covered by 5 main committees, so including power systems, hydrogen, carbon capture, utilization, storage, and onshore wind. The fuel quality measurement and handling, that's delivered via 4 main committees, so including aviation fuel handling, test method standardization, hydrocarbon management, and fuels distribution. And finally, the safety, health and environment theme is delivered via 5 main technical committees, including process safety, managing human performance, aging and life extension, environment and health. So these are the technical partners that we work with who fund our technical program, and that grows every year. So there's more companies and organizations interested in the work that we do. So currently we've just over 40 technical partners involved in the program. And as I mentioned, they fund our annual program, our technical program work. The Hydrogen Committee, this is chaired by Donald Smith, who unfortunately was unable to make the webinar today. But just on his behalf, I'll just introduce the Hydrogen Committee. So it was first established or we started to set it up in 2019, and we held our first Hydrogen Committee meeting in November 2019. And recently we actually held our 10th Hydrogen Committee meeting. The committee itself comprises over 40 members, including energy companies, regulators, academia, and independent experts. And it looks to help identify and address the regulatory, safety, and technical challenges facing companies wishing to be involved in the hydrogen space. So this just shows really a timeline of the activities of the hydrogen program. So as I said, it was firstly established back in 2019. It took about a year to set up and to make engagement with the relevant stakeholders. So we're established about 3 years now. And so in January 2019, we held our first energy transition stakeholder workshop. And the key themes identified for us to work on was CCUS, hydrogen, and integrated power networks. And subsequently, we set up committees to handle those themes. In October 2019, we held specific workshops on CCUS, hydrogen, and integrated power network stakeholder workshops. And for the hydrogen one alone, we had over 100 participants in that workshop. And from that, we identified a number of priority topics to work on. Those topics you can see there on the screen. And the first set of topics, which were 6 back in 2021, you can see infrastructure integration came out of that as an output, as a priority topic to look at. And following on from that, then in January 2022 and January 2023, we sourced more funding from STAC to develop further on the hydrogen program, with further topics being worked on. So much of this work is multi-phase work. There are very big topics and projects. So with phase 1 mainly being like more research and gap analysis work. So this just outlines all the various working groups that we have set up to deal with the whole range of projects that we're delivering on. And most of these working groups comprise of subject matter experts from industry. We have a number of publications published to date. So you can visit our website and just click on hydrogen and you can see the range of publications. So there's 6 or 7 published so far, with another few due literally within the coming weeks. So keep an eye out for those publications. Oh, I think I skipped a slide. So this just shows the hydrogen value chain, and those green boxes, those green areas, are the areas within the Hydrogen Committee remit. So we work on production, storage, transmission, distribution, and use, with those highlighted in red being dealt with by other organisations. So that's just, as I say, an outline of the sort of the scope or the remit within the Hydrogen Committee. And just the next few slides are literally just a list of the topics that we're working on. Some of them are ongoing, some have been delivered already. So as I said, they're multi-phase, with phase one mainly looking at gap analysis work. And so all of these highlighted in green have been published already, so they're available to download. And HY 2003 is going to be published quite soon. These projects are ongoing. Apart from HY 2204, we already held a webinar on that, and that's available, so has been published. 2023 projects, and these are all ongoing. And Power Systems Committee has a project on green hydrogen. That's P2301 to P2303. So that's due to be published fairly soon as well, within, I would say, the coming weeks. And we have some projects outlined for 2024, which we've secured funding for. So I hope that's all clear enough as to what we do at the Energy Institute and Hydrogen Committee. And I'm going to hand over very quickly now to Nigel to introduce the project and the work that you did.
Thank you, Tony. So yes, this is well, in fact, the next slide is if you can skip the next slide and go to the there, that's perfect. So what I'd like to do is just a quick introduction to Penspen, to give our background, which gives a context to the perspectives that we've generated. The presenters we've already introduced. Background to the project, the objectives, the scope that we undertook, methodology we adopted, which I think has some, with some interesting points there. Obviously, the results, the key meat of this talk, and any sort of further considerations, and then we're very happy to take questions and answers. Next slide, please. So next slide again. So just a little bit about Penspen. So we're an energy infrastructure consultant. We've got about 1,000 staff. So we're have a global reach. Main offices in Abu Dhabi, Houston, and London. And in the UK, we've got offices in Aberdeen, London, Middlewich, Neath, and Newcastle. So next slide, please. So in terms of what we actually do, our traditional business, I would say, was engineering and project management. We do concepts, designs, and feed for and detailed design for that matter for energy infrastructure. So that's the main activity of Penspen. Project management is becoming increasingly more important. We have a project management consultancy looking after our clients' projects on a very large scale. And asset management as a business has grown. We actually have a whole fleet of people that drive around the country in vans, servicing gas related infrastructure. And in the US, we operate a lot of operators' assets as well. So asset integrity is the business I ran for a few years. That's effectively part of the portfolio of risk management principles that the operators have, dealing with sort of pressure containing equipment. Training education, we've got a training centre down in Neath, which provides training to operatives. We also have a number of online courses, and we provide public and private courses for a whole variety of different topics. We also have a digital business called Thea. Thea is an encapsulation of our asset integrity, the technology that's developed through our asset integrity business, into a software as a service, which is a product effectively. So that's our services, and they're general to energy infrastructure. So next slide, please. In terms of hydrogen, obviously it's an emerging business. So the first two we're already extensively involved in. That's designing and building in new hydrogen and CO2 infrastructure. So we've been extensively involved in designing new infrastructure, and also repurposing. We're looking at a whole country transformation over to blends of natural gas and hydrogen. The second two, I think, are sort of aspirational for us. Obviously, we'd like to, as we do with natural gas, to provide services related to the operations of hydrogen and CO2 infrastructure. So not much of that actually happening at the moment. So, and of course our maintenance services as well, equally applicable. So next slide, please. So just a little bit a background to the work that we've undertaken for the Energy Institute. So next slide, please. So the Energy Institute naturally supports the UK's goal to achieve a low carbon energy system. So HY 2005 working group was established in 2020 to identify and address common industry issues around infrastructural integration. So the working group's objective is to understand where gaps exist in terms of knowledge and practice. July 2022, the Energy Institute issued an inquiry, went out to the market for a proposal, and the work was awarded to us, which we're very grateful for. It's been a very interesting project. So next slide, please. So in terms of the study objectives, I think next slide, please. So Ian touched on these really. So it's really the interfaces between producers, off-takers, and the network. So how you connect to the network in terms of putting gas into it and taking gas out of it, and this is from the owner's perspective. So actually speaking to people developing these interfaces or contemplating developing these interfaces in the future. So in terms of deliverables, we were tasked with providing a summary of the interface definitions for each of these. What does it actually look like? And where general interface agreement is understood, assess the variety or identify where interface agreement is understood, and assess the variety of interfaces for commonality. So, and where a lack of alignment is identified, specify the interfaces that need to be developed. Where are the gaps that need to be filled? Next slide, please. So this is actually given to us by the Energy Institute, and it's a picture of the UK's potential future gas network. The dark blue is the national transmission system, and light blue is the local distribution system. So these are all the future users, storers, and producers of hydrogen, and it's considering the network as 100% hydrogen, also the network as Hythane, in other words, a mixture of natural gas and hydrogen. So not many of these, some do, but not many of these currently exist. They're mainly are plans developed with some level of certainty in some cases. So just quickly going through them, we've got large reformers, that's steam methane reformers or autothermal reformers, or in fact they could even be partial oxidation, close to sites of sequestration, associated with industrial clusters potentially. And we've got onshore and offshore renewables. So this is implying that through electrolysis that hydrogen will be produced close to where the renewables are, and the transmission network will be national transmission network will be actually used to transport hydrogen from production to users. And then we have gasification, nuclear, shipments of liquid hydrogen in and out. We know that some nations are planning on producing large amounts of hydrogen, possibly as ammonia, possibly as liquid hydrogen, and creating a world market effectively for hydrogen. Interconnection to and from other countries. You'll know we're already connected to Ireland, we're already connected to Belgium and the Netherlands, and to Norway with interconnector pipelines. So to what extent they will be used for transporting hydrogen from the continent to us, from Ireland to us, or the other way. So then we have large industrial users. That's typical power stations, and many power stations are connected pretty much directly to the national transmission, providing our power. And large storage entities. Rough is a good example. Was the largest storage entity, and it has plans to transfer that to hydrogen as well. So then switching over to the local distribution system, lower pressure via an offtake. So we have much on a much smaller scale, local producers and local storage. And local storage could be pressure vessels at 700 bar, and then providing to users aviation, probably sometime in the future, shipping. And then, of course, mobility, we're meaning here trains and filling stations. I mean, there are existing filling stations, small industrial users, and of course residential users. Our homes. and there may actually be local reformers as yet. We didn't actually come across any of those. Now, there's two possibilities here. Some of these users will actually more likely get their gas delivered to them by tube trailer, and there are some technical reasons for that, particularly the filling, the filling stations, and potentially aviation. So we did consider that. And in terms of infrastructure that's currently existing, that actually does exist. There are actually people that are producing hydrogen and shipping it around using tube trailers. So of all of these are the ones that do actually exist right now. So next slide, please. So in terms of scope, in scope was the transmission network connections, anyone wanting to connect to the network to put gas in or out, the distribution networks, and as we just discussed, the road tanker distribution. What wasn't in there was the the upgrades required to the actual network for hydrogen or Hythane. That's part of other Energy Institute projects, and also port-based interfaces, again, a part of other Energy Institute work. So our real focus was on talking to people, contemplating making connections to the transmission network or distribution network via pipeline or even tube trailer. So next slide, please. So talking about the methodology, so there were projects before us, and also we've had our own experience of trying to reach out to large numbers of individuals to get a consensus. And our experience was that sending out questionnaires, particularly when those receiving them might view that most of the questions aren't relevant to them, but not realizing that the bits that are relevant to them are still of interest, don't fill them in. So we've historically, through our own work and overseeing others' work, that you get a very low response rate, less than 10%. So really, we realized to get to, and in some cases, there were only one or two entities considering interfaces to the network. So if your hit rate's only going to be 10%, then you may not hear at all from some people, which obviously was a worry. So we had a different strategy. We actually identified all the people we wanted to talk to, and then emailed and called them systematically to actually identify individuals that were working on the interfaces, specific people or groups of people, and then actually arranged a meeting with them and went through the questionnaire and completed and put their answers into a database. So we found that was an effective way of working compared with the questionnaire, but extremely labor intensive, I have to say. So the other, I'd say, we'd like to say innovation was, part of our remit is to look at defining the interface. So we thought rather than starting from scratch with each individual respondent or interviewee, we actually produced a whole family of conjectural interfaces for each of all the 26 that were defined by the Energy Institute. So of course these don't actually exist now. So they were actually based on natural gas facilities or tube trailers or things that do exist for tube trailer transportation. So this was really to focus the meetings. So we have a series of slides, we can go through them and get the attendees of the meeting to agree or disagree or help us adapt these. So the delivery we produce has a whole set of these interfaces. So really, I think the interesting thing here, of course, is the results. But I thought it was worth just talking about the approach because we found it quite successful, and we had high rate, 52% response rate basically. So 52% of the people that we wanted to talk to, we ended up talking to and getting a response from. So that contributed to the study's success. So next slide, please. So this is an example of an interface diagram. This one is an interface between the national transmissions, the local distribution system and local storage. So you can see we defined here that the blue is the local distribution system, and the green is the facilities that we were discussing with the producers or off takers. And the components here. One thing is, where is the interface between the two? Where's the connection point? To what extent do you need isolation? Where does metering occur? And in this one, of course, you've got pressure reduction. The likely scenario for local storage is 700 bar. So you need pressure reduction, obviously, to get it back into the local distribution system, and obviously compression to put it into storage. So and and blow down potentially for maintenance. So that's an example of an interface. So we produced a whole family of those. So next slide, please. This is the list of organisations that we set out to talk to, and this was obviously a while ago. So when some would have been added to this now, and please forgive me if you fall into one of these categories and weren't contacted. We defined an interface 0 as well. This defines very, very important stakeholders that would have an important view, but not necessarily specifically related to one interface. So interface 0. So that would include all the industrial clusters, because a lot of these industrial clusters actually include multiple interfaces. Sometimes half the interfaces here would be dealt with in an industrial cluster. And then, of course, the transmission networks themselves, the important other side of the equation, effectively, and then the regulator, Ofgem, the government, the health, safety executive, and IGEM, Institute of Gas Engineers and Managers, has been very influential in producing standards and has a whole family of standards that have been used for the gas networks for decades. So, of course, they're a very important stakeholder as well, and we know they're doing quite a lot of work in the hydrogen area. So 85% of these were contacted. I think the ones that weren't, it's where we just couldn't come up with an email address. So 85% were contacted, and say I think it was 52 or 53% of them we got an input from. So next slide, please. So in terms of results, well, we certainly updated these interface diagrams. This example is for offshore wind, and we talked to offshore wind that we're considering converting to hydrogen, interfacing with the network. So we got the NTS pressure wrong. It was we had 38 to 85 bar. Actually, it's 38 to 95 bar. So there was some discussion about odorization, and the general consensus was that GSMR, which was the gas safety management regulations, which manages the safety of the existing network, as we call it, indicates that anything above 7 bar doesn't need to be odorized. So general consensus was that will be consistent, and we know that odorization, SGN have done a lot of research on it, does work quite effectively with hydrogen. So the conjecture of odorization being included on the facility side was removed for this particular one. So next slide, please. Then in terms of the headline results, headline results is, I think those following what's happening with the networks and blending is that there's no real decision on blending. There is a plan to have a decision in 2023, and there was a recent consultation process the government went through. There's a hydrogen transport and storage consultation, and those results were published in August, so very, very recently. On the subject of blending, they said that they were going to go through a consultation process on blending prior to the 2023 decision. So considering we're in August, so there isn't much time to do that. So we still don't have a decision on blending. So so the requirement there, obviously, that the next point is highly related. So the requirement for repurposing is not clear. So if we're not blending, then the infrastructure will still be used for natural gas until it's not required anymore, obviously, or can be reused for a dedicated 100% pipeline. But the network as a whole wouldn't be transporting hydrogen if the decision for blending is that it's not going to be used. So the responsibility of developing and owning and managing infrastructure is not clear now. We've got lots of clients that use gas from the national transmission system or the local distribution system, and they've typically in the past built their own infrastructure. So they build the offtake. The offtake will be built by the network, but they build the pipeline, they'll build the pressure reduction station, they'll build block valve stations, they'll build all the metering, and that will be their responsibility for designing it, for constructing it, for acquiring the land, and then operating it as well. So there was a plan probably 20 years ago for that infrastructure to be actually adopted by the networks, but in practice not much of that actually happened. So the question now really is with future networks and hydrogen is whether that process is repeated, and that it's up to users and producers of hydrogen to create their own connecting infrastructure and own it and operate it, or that will be provided by the networks, or indeed possibly in even a third party, another entity that has a business basically of connecting infrastructure together and is paid in some way. So so really the fact that that what's happening with networks is unclear, has led a lot of developers to consider their own infrastructure, and there's been a proliferation of that. And not all of it's aligned, and some of it's actually duplicated, and some of it indeed duplicates what the national transmission system could actually provide. So so really, because of the independence of producers and users of these projects being developed, I mean there are some interfaces being proposed, but not not many. And I know Hythane is planning on is designing an interface with the distribution system, but of course that's going to be in abeyance on the decision on blending. So next slide, please. In terms of regulatory and commercial concerns, the regulatory framework for gas needs an overhaul to take account of hydrogen. Absolutely right. I mean, the government is very aware of that. They've come out and said that they've committed to producing a business model for hydrogen transporting by 2025. The regulatory framework, they're planning on updating it and then producing amendments in a timely fashion. That's their sort of current statement. That was in the August 2023 announcement. So some uncertainty in terms of controlling codes and standards and guidance. Much of it is actually being addressed by the pilot projects. We've got a lot of projects that are going on, and they are really addressing all these important issues. And that material is being published, but they're not necessarily all connected together, and not always coming out in time to be useful for projects. So and one very key concern, I think, with anyone contemplating using hydrogen is the security of supply. So funding, another thing as well. And again, there's been announcements there. I mean, the hydrogen transport infrastructure is going to be on a regulated asset base. So it'll be also similar to the gas networks. So and on storage, the statement there was that it'll have a floor to mitigate demand risk. And these are important enabling policies. Next slide, please. Skills gap. I think it is considered. Most of people we talk to do consider it to be a barrier, and I think it's reskilling existing human resources for hydrogen in projects. Obviously, there's a lot of people understand about building gas pipelines and operating gas pipelines. So it's a question of skilling up for the differences. The skills in transportation of hydrogen are minimal at the moment. So there's a limited availability of broad management or operating skills in hydrogen. So we know that BEIS, IGEN, and EUS, that's the energy and utilities skills. If you're not familiar with that, they're actually collaborating to produce competency frameworks and safety standards for hydrogen, which I think is it's going to be incredibly important for an enabler for moving forward. Next slide, please. So these were common questions that came up in our interviews and points of consensus on the networks. I'm sort of slightly repeating myself here, so I apologize. So the local hydrogen transmission networks, the uncertainty in terms of their time frame, is a key issue for people to be contemplating using the networks for transporting their hydrogen production. Again, the responsibility of ownership of connecting infrastructure is unclear. A lot of users, producers, and off-takers want that to be provided by somebody else. They don't want to have anything to do with it at all. Basically, they just want to produce hydrogen, have somewhere to put it, or just take it off. So that's something that needs to be, obviously, is an important point that needs to be resolved in the future. Currently, the gas networks work on a uniform network code, and that's really important to allow shippers to understand how that works. So it has a neutral perspective on it's an open business effectively. So with the gas system being national infrastructure that can be used by, effectively used by anyone to ship gas. So how's that going to work with hydrogen? Because it's not completely straightforward blending, because obviously if you're limiting blending to 10%, for example, for material considerations, then once 10%'s in there, it's in there, and no one else can, downstream can actually add more. So also people get it whether they like it or not. So, and then at the moment the network is fairly uniform. You put gas in one place and you take it out. One molecule is the same as the other pretty much. But with blending, it may not be. You're going to have different proportions of hydrogen in different parts of the network. It's not all going to be the same. Not all going to be the same percentage. So that does change. That does change things a bit. So those issues need to be sorted. That's sorted. This point about at the moment we have metering asset management is like a separate. That's a separate business or a separate entity. So maybe we have similar such things with hydrogen, where some elements of the infrastructure will be owned by others, and that will be regulated as well. So naturally, connection to the NTS is much harder than the LTS. You need the capacity in the NTS. You're talking about high pressure, large diameter pipelines. So any changes? There's some question marks over changes in the odorization requirements. We're assuming not. Currently, it's not required above 7 bar, which is under the gas safety and management regulations. So the expectation is that it will be very similar to it is as we have it right now. So next slide, please. So we took the liberty of modifying the Energy Institute diagram slightly and added in 100% hydrogen network. So that's the light green, because I think almost certainly that's going to be the scenario. We're going to have the existing national distribution system, local distribution system, and 100% hydrogen networks all working in synergy with each other. The 100% hydrogen network will almost certainly adopt some of the national transmission system for 100%, but they'll continue to operate in synergy with each other. So next slide, please. So common questions and points of consensus on hydrogen. Quite a few of our meetings, the security of supply was mentioned, and in fact, quite a few people said, can we switch back? And I think for all the infrastructure to be there for you to operate with 100% hydrogen and 100% natural gas, from a user's technology point of view, it's very unlikely you can easily switch between the other and another unless you keep all that infrastructure in place. So I think the key issue here, the reassurance, I think, is down to security of supply. So that's multiple producers connecting multiple producers together, and that I think that's the purpose of some of these hydrogen, these hydrogen backbone type projects. Creating security of supply, and also storage, incredibly important as well. So you can sweat the hydrogen producing assets as much as possible. So road tanker, pretty much everybody we spoke to, it was gaseous transportation, but I think liquid will have a place. Liquid transportation will have a place. There's a requirement for hydrogen leak detection technology. Obviously, there's some concern about when introducing hydrogen leaking. So methodology there in terms of do you proof test with helium first? Do you just put sensors? I know recent work has indicated that if it doesn't leak with natural gas, it won't leak with hydrogen. But if it does leak with natural gas, it will leak more with hydrogen. Purity is another issue. I mean, you almost have to think of hydrogen in two ways. There's the hydrogen produced by steam methane reformers, which has impurities in it, and that's perfectly okay for industrial heat and domestic heat, but not good for fuel cells. Fuel cells are poisoned by impurities, including potentially odorization. So you almost have to consider two supply chains. So it's either two supply chains, fuel cell applications making their own hydrogen on site, or transporting very pure hydrogen in tube trailers or as a liquid, and the rest being provided by the transmission system, local transmission system. So other issues are raised, lack of codes and standards. I mean, there are some, but not the whole set that we have for natural gas. So I think I'll move to the next one. Thank you. So in terms of gaps in the framework, technology gaps are actually found to be quite limited. And that's really because, the hydrogen pipelines do already exist. there is hydrogen produced in refineries, and most of the demonstration projects are dealing with these issues. So I mean, the high deploy H100 and H21 are good examples, and they are providing a much greater understanding of what's required. They're also dealing with public perception. I mean, they're well publicized. They have excellent sort of PR pieces, demonstration facilities you can visit. So and they've got houses with appliances. So I mean, they're really addressing a lot of these interfaces. If you're talking at a high level to most of the people we talk to, they're more concerned about the economic and political gaps than they are about technology. So it's what's going to be the funding mechanism for the larger projects. It's clear with the earlier stage projects, some of that funding is coming from the government. But when you actually start to cut metal, buy metal, acquire land, then the cost becomes huge compared with what's actually being spent at the moment. So, and safety regulations, what's going to happen with what's already there, GSMR, for example. Next slide, please. Custody, and that's one of our questions. Where does it change custody? And we talked a little bit about that already. Some uncertainty where it changes custody, where it goes to be the responsibility for the network operator as opposed to the user or the producer. This brings in this point again about whose responsibility it is to build the connecting infrastructure. The above ground installations, the metering, etc., etc. Some developers talked about having meters on both sides of the fence. Currently, that's generally not the case. Generally, it's only on one, and it's effectively a shared and carefully managed asset. Some stakeholders suggested the custody transfer would occur at the isolation valve. Some had different views. So next slide, please. In terms of codes and standards, we've been using a lot of these. IGEM have been doing a great job. They've got TD1 which is based on ASB B31.19 to a certain extent. But that's for pipelines. They've got TD13 on pressure reduction stations. With their good supplements. TD3 and SR25 again hydrogen. ASME B31.12 is pretty comprehensive. That's for piping and pipelines. That's being used with our European clients. And I know that the pipeline stuff is going to be taken out of there and put into B31.8. So I'm pretty sure about that. So it will just be for piping and piping B31.12, but 8 will include hydrogen. So, and then we got PAS 444, hydrogen gas appliances. There's also 2 other entities which have got some excellent hydrogen-related documents. There's the Compressed Gas Association and the European Industrial Gas Association. They've had standards for a while related to hydrogen. So, and ISO. Aviation is very early phase, very early phases really. The use of hydrogen in aviation, they can do it for short hop planes as compressed hydrogen, but really for long distance, it's got to be liquid hydrogen, and that requires substantial modifications to existing fleets. And the time frame for these is 20 or 30 years to develop it, and also delivering liquid hydrogen through an existing hydrogen system is not possible. So the whole way in which planes need to get fueled with liquid hydrogen will be different because of the size of the planes change, the whole layout of airports, loading and unloading and passenger access will change. So it may be that aviation will go down the sustainable air fuel, the circular, using direct air capture to capture CO2, combining with hydrogen to make synthetic fuel may be a more logical route for aviation, because you can use pretty much all the same infrastructure. So we didn't get a lot of uptake on our discussions with aviation. So we know the HS is doing a lot of research on the QRA for hydrogen practices, because they'll be the entity sort of signing off on this at the end of the day. So it's kind of in everyone's interest that a methodology is agreed. So next slide, please. In terms of common questions and points of consensus on consumers, currently UK filling stations, we talked to a few. They're making it on site. I mean, I know Beaconsfield is a filling station close to where I am right now, and they actually make theirs on site. That's been operating now for a while. I know the Perivale, which is the West London filling station, which is used by the London buses, gets his hydrogen delivered from the northwest Runcorn. So we've got both going on. So point on the right, I just talked about air transportation. I think is some way off. Maybe that SAF is a stepping stone, or maybe that sustainable air fuel is the way it goes permanently. So filtration and purification is a key issue. I've already talked about that. That's the difference between hydrogen for fuel cells and hydrogen produced by SMRs or ATRs, and again, there needs to be a good return on investment for large installations, of course, for this. So next slide, please. In terms of skills, a lot of the people we spoke to were from the oil and gas background, which is obviously a declining workforce. So we need to see how these would keep these additional skills will be developed or create knowledge suitable for hydrogen expansion. So we also need the breadth of skills for early stage projects. We found that with respect, a lot of people we talked to had quite a narrow respect for their project, but not a broader knowledge of hydrogen or how it fits in. So and we know that Bayes and others are working on critical competency standards to help with skills. So next slide, please. So in terms of further considerations, there were a couple of things that the Energy Institute sort of raised as part of our scope. So it's about technology maturity and the supply chain. So I think one thought we had is actually trying to quantifying it. So achieving net zero obviously requires a lot of infrastructural development. So the nature of demand there are different pathways to net zero. There's electric, for example, electrification versus natural gas. So I think understanding the range of possibilities in terms of infrastructure required, I think would help with the skills depth. And there are various bits of work that have been done on that, including the national grid's future energy scenarios, where they looked at the whole range of different potential scenarios. I think that work could be used to come up with some estimate of skills gaps. So next slide, please. And the other one is on on really bringing everything together into one place. I think to resolve critical differences in understanding. I think a lot of what's required exists, but it's not in the same place. So I think we thought a valid contribution for the Energy Institute would be to try and bring that all into one place, and they're doing that already in a lot of other areas. So bringing the current status of knowledge, or even just linking to the research that's being done and keeping making people aware of it, I think would be very important. So, and I think that's my last slide. So next slide, please. I think it's
okay. Thanks. We're actually running out of time. But Amy, are we able to extend by a few minutes, or are we cut off at 1?
Yeah, of course you can extend.
Okay. Well, we'll take the questions that are in the Q&A then. So, Ian, do you want to cover these?
Yes, please, I can. Yeah. Thank you, Nigel, and your team. It was really good piece of work. And we have got a couple of questions. We have 3 questions here, and I have 2 from myself. Yeah, let me start from Ian Parker. He's talking about the ASME pipeline code for H2, and I think it is the B3112. He said that it has restriction on pressure and water content, and he believed that there is a GIP led by DNV to update. Are you aware of any specific areas that are being addressed?
Yeah, because B3112 has got 2 design options, option A and option B, and one is you effectively reduce the pressure. You limit the stress in the pipeline material. So that means for an existing pipeline, you have to reduce the operating pressure. The other method, option B, is you actually test the material for its performance in hydrogen. So you have to do fractional mechanics testing basically. So that's the approach in B3112. There's another emerging approach as well that's produced by the German networks from GWDV. Have done lots of experiments, and they don't consider the static or fraction mechanics of hydrogen in a static mode, but they consider it from more of a dynamic point of view. So looking at the fatigue performance. So yes, I'm aware of that. I'm aware of that GIP. We're actually contemplating joining that GIP because from our point of view, we have a good understanding of how to apply B3112, but you need the data, of course, to apply it generally. So in terms of
Okay,
water,
thank you.
yeah, the GSMR does. I don't think is clear on water content actually in natural gas. That's been a point of controversy for a while. So.
Yeah, that's good. Yeah, and then second one is from Matt Foster. Yeah, he believed that the GT gas turbine and that they should get 100% natural gas for startup and shutdown. I'm not sure what he's asking for, but maybe he's saying what type of branding
Yeah. So you're
you
going
may
to be
come up
using.
to.
Okay, yeah. I'm not so familiar. To be honest, I'm not so familiar with that. So they're saying. I think they're saying that you start off with 100% and then switch to a blend. So the question there is, how do you provide a blend and natural gas? So that's requiring so you will need effectively two connections to the network. So to be able to do that, because once the hydrogen is in there, how do you take it out again? So you can actually do that, but it's probably may not be cost effective. So
Yeah, I think this one has been under review with OEMs, which produce these gas turbines, to see how they can accommodate that. I'm not aware of any outcome from that. Okay, and then from anonymous attendees is talking about multi-phase pipeline, and I believe that is not in a scope of phase one.
which sort of pipeline was that? Sorry.
Yeah, he's talking were multi-phase pipeline considered for the study.
No, we didn't.
No.
No.
And then the other one from David Gucci is a method of carbon dioxide quality for CCUS available.
That's something that quite a few people have raised. I mean, obviously, I'm sort of talking here about what people have said, so I'm sort of answering these questions from my own kind of knowledge. Yeah, but carbon dioxide quality is obviously incredibly important, because if you need common transportation of it, then you've got to have some kind of standard. Otherwise, you're going to get potentially contaminants reacting with each other and corrosion and things. Yeah. So that's I think that's something that is required, and it may be done on a project by project basis, but I'm not aware of an actual standard for that. So, but I think it's required.
Oh yes, and the question came in. In your view, what are the biggest risks associated with transition from natural gas to hydrogen?
The biggest risks. I think we can manage the technical. I think we can manage the technical risks. There's a lot of work going on the suitability of materials and testing. There's standards from iGen. I think the risk is more commercial than technical. It's just how do you make it? If the risk is, we're talking about risk of achieving net zero, is one kind of risk, isn't it? And then there's risk to people. I think the risk to people, I think, can be managed. We've done that before. We did that when we switched to natural gas. I think it's the risk to not making net zero is the key one, and I think that comes down to the commercial frameworks that make it cost competitive and make it work for domestic users, industrial users, producers, etc. I think that's the main. I see that as the main challenge. That's my view anyway, and I think most of the people we talked to said that as well.
Okay, thank you. And one from me. Yeah, from the SSC perspective, yeah, this month it was announced that the two SSC project has gone through to the final stage of funding, and one of them is the thermal Obra Hydrogen Pathfinder, and the other one is a renewable Golden Bush Hydrogen Project. Those two major project for SSC. And from your point of view, how does the UK compare to other nations in terms of networking utilization?
Yeah, I mean, we're familiar with some of the European gas networks, and we're doing some work in Portugal, for example, and they've made it really, really clear. They've obligated the gas networks to transport certain percentages of hydrogen in certain times. So, for example, 10% by the end of 2024, 100% by 2025. So that makes it really, really clear to producers. So if you build a hydrogen production plant, you can really, or if you plan on building a hydrogen production plant, you're fairly confident, where you're going to have somewhere to put it. So I can see a bit of a difference. There's more clarity on how the networks are going to operate. I mean, I'm not talking about collaborations between network owners, but from the government. The government is saying, the network's going to transport hydrogen, and it's going to be available for users at these times. So, and then the network operators are obligated. I'm not saying that's right or wrong. I'm saying that's the difference. That's the difference I observe. So,
yeah, okay, thank you. And another question came in from Seb. How much competition is estimated to come from heat electrification, and would hydrogen offer competitive cost considering the infrastructure and technology installation requirements?
I think it depends what you're doing. I think, and it depends on all these policies and standards. I think. I mean, it's all these policies that are going to be put into place. I mean, hydrogen in a lot of cases is going to be more expensive, but it's the only way you get to net zero. I think, and I think will it be competitive with electrification? I guess if electrification is coming from renewables, the transportation and storage of electrical current is more expensive than hydrogen. Very easy to store large amounts of hydrogen. So it may be from a big picture point of view, consuming hydrogen may actually be cheaper than electrical current when you consider the storage and transportation into it. It's quite a big question to answer, but could possibly be cheaper hydrogen than electrification.
Yeah, okay. Another question. Although it is outside the scope of your work, what do you think about liquid hydrogen?
I think liquid hydrogen is you can't really put it through a pipeline because it has a low, well, not for long distances anyway, because it has a low specific heat capacity, but you can certainly transport it in a vessel. I think liquid hydrogen could be a way of transporting hydrogen around the world like they do LNG. I think if you're thinking about trains, then gaseous hydrogen can't provide the energy you need. So liquid hydrogen may be a better way of doing it. Same with long distance air transportation, sustainable air fuel, but potentially liquid hydrogen could be a way of making it work for plane long distance air transportation. So it'll have a place. Have a place. Obviously, as you transport it, you lose some of it. You lose heat to the environment. Some of that can be recovered. So it'll have a place, definitely.
Yeah.
It may take a while in the UK, but
Okay. The last one. What was the level of diversity when stakeholders reviewed the interfaces? Example, largely aligned or differing?
There's a fairly consistent. We didn't get a lot of would have highlighted in the report. We didn't get a lot of contention between different stakeholders on the same interface. So.
Okay, good. That's all the questions. And what I can say now is the phase one is completed. We have seen the gaps and concerns, which is going to be included in the scope of the phase two. And our next group meeting is going to start drafting the scope of phase two. And I think that's all for me. Thank you, Nigel, and your team. It's up to Tony now. Thank you.
Yeah. No, just want to thank everybody for joining the webinar. I think it was really good, very informative from Penspen, and thanks to Penspen for delivering that presentation. And yeah, so I think we'll end there. We're a little bit over time, but that's fine. So thanks very much again to everyone for joining, and hope to see you at the next webinar. in fact, I do have a slide on that. I forgot. Which is, yeah, so they're listed there. So the next one is on the 5th of September on tripod light. Next one, 27th of September, safety on incident data, and 31st of October, green guide guidance. And there's more scheduled for next year as well, Q1. So keep an eye out for those webinars. And just any contact, or if you have any further questions, just contact myself and my colleague in relation to this topic, Hydrogen Committee, the Technical Innovation Programme, or if you want to become a technical partner. So thanks again to everyone for joining.
Thanks for listening.
So we can end it there. Thank you.
Thanks.
Thanks, everybody. Bye then.
Bye.
Bye.
Just said it's going to be a